without an NPU, you wouldn't really be able to efficiently run those. And I think that those are sort of some of the sort of future ways that people are going to be using these sort of tools. I think as
So
we move into
you really think having that like that personal generative AI sitting, maybe we should call it Genie, a personal genie.
a personal genie, yeah.
Or Janae. There you go, Janae. Welcome to Embracing Digital Transformation, where we explore how people, process, policy, and technology drive effective change. This is Dr. Darren, Chief Enterprise Architect, educator, author, and most importantly, your host. On this episode, Personal AI and Privacy First, how NPUs and AI PCs disrupt public generative AI, with special guest Dan Salinas, Chief Operating Officer from Lakeside Software. Dan, welcome to the show.
Hey, Darren, how you doing? Good to be here.
I'm doing pretty good. It's been a busy morning already here in California where I'm at. And today we're going to talk about a new platform of computing that's just, it's really incredible what you're able to do with it. And we're going to talk about that and the impacts on that. But before we do that, Dan, everyone that listens to my show knows that I only have superheroes on the show because I would never have anything less. And every superhero has a background story or an origin story. So, Dan, what's your origin story?
Oh man, so many there, but I guess the thing that is the most maybe unique thing about myself has nothing to do with myself in some way. So my fantasy football team name is Quadfather, and the reason it is Quadfather is because I actually have quadruplets. So,
Well, that's you. That's awesome.
yeah,
Are they identical quadruplets or?
so fraternal, two boys and fraternal, 2 girls. 19 years old. They just went off to college actually. So my wife and I are empty nesting.
Oh my goodness, what a journey. That must have
Yeah.
been an incredible journey, right? I mean, but I
Well,
tell people
I don't remember the first 4 years of their lives. So there's pictures, but oh my God, I guess I was
because you
there.
didn't sleep for 4 years.
Well, I mean, with kids, you don't sleep anyway. So I guess
No, you don't. You
I
don't.
guess, there's only so much sleep you can lose, I suppose. But,
Oh, Dan,
yeah.
that is really amazing. I have 10 kids, and I always tell people the odd number kids are the hardest. Meaning the first one, and because it's life changing. Having a child
Yeah.
is life changing, and then the third one because it's the first time you're outnumbered. But when you have quadruplets, you get all that all at once. That's
Well, I
incredible.
mean, we struggled with the first one, but we had it figured out by the fourth one. I mean, we really, you know, 4 minutes in
Oh,
between was plenty of time, you know. Well, 10 kids though, that's a that I can't even, I don't after
well, I can't even
the 4,
imagine
I can't
having
even imagine having
quadruplets.
more.
Oh, man, that's so awesome. So with all that great knowledge of playing defense,
Mhm.
and coordinating, how does that apply to what you do in your day-to-day life?
Well, I suppose learning to balance time
Oh, wow.
is an important thing. It's as they've grown up, you
Mhm.
realize, how valuable that is, and you want to work on things that are impactful when you're in your job world. Um, uh, I guess I take it from there. I mean, um, I've really
Mhm.
been lucky that I've had a bunch of organizations I work with that have been very supportive of it. So
Well, that's awesome. So, hey, let's dive into the topic today. I mean, AI PCs were unleashed on the world about 2 years ago,
mhm.
kind of, right? So we've heard the term. What in the world does it mean?
Well, I mean, I think it's basically being able to use the compute power of a PC at the edge to run these advanced AI models, right? So instead of spending all your money in the cloud, you can leverage the power of a distributed device to use the AI engine. I mean, it could be as simple as um, leveraging the when you're on a Zoom and you're running these funky backgrounds that need you know good power to run them. So you can use it that way, or you can run local LLMs. And some of the software vendors are starting to take advantage of that. Um, Systrack being one of them. Actually, we run we analyze our data using NPUs. So
All right. So you mentioned NPU. This is a new term that a lot of people have never heard. I know what it is because I work at Intel. I know what NPUs are, but can you explain this new? Because most people are used to, hey, I buy a laptop. It has a CPU in it, a central processing unit. I have maybe a GPU, a graphics processor. So what's this concept you mentioned NPU? What's that all about?
well, I guess it stands for neural processing unit, really. So it's really focused on performing AI and machine learning tasks. Um, I think GPUs can also do AI tasks, but NPUs being neural processing units, they can perform. They're more tailored to perform AI tasks, so they're more specialized than GPUs. They're more efficient.
Well, I like the word efficient because they're tailored specifically for that type of workload. So
Yes.
we can decrease the power dramatically by doing this, right?
Right. Right. Yeah. GPUs take a lot of power, so you could tell with the fan spinning in your laptop when you're using your GPU versus your NPU.
Yeah, the fan is actually on when you're using the
Right.
GPU.
You're right. It's spinning like crazy. Yeah.
So what kind of use cases do you see this new processing unit kind of open up to the world besides the I mean, you mentioned, oh, I can run a large language model on my laptop now. So what? Or I can do better blurring on my Zoom. Meh, I have that already. That's cool. But what is this bringing me that's so different?
Well, I mean, I think you think in terms of like where we're going with using personal LLMs. Like, do you want your data to be in the cloud shared with all the providers that are basically learning for your data, or do you want to have something private to yourself from a security perspective? Without an NPU, you wouldn't really be able to efficiently run those. And I think that those are sort of some of the sort of future ways that people are going to be using these sort of tools. Um, I think as
So
we move into
you really think having that like that personal generative AI sitting maybe we should call it genie, a personal genie
a personal genie, yeah,
or Janae. There you go, Janae. A personal Gen AI running on your laptop means that your data is not leaving your laptop. That's huge.
yes,
I mean, that's gonna cut into OpenAI and Gemini and all the things. Can it do everything that those models can do running these large or small language models on my laptop? Can they do all the same things that the big ones can do?
well, I think if you look at like when you're using ChatGPT, you'll notice that when it's doing its reasoning, a lot of
Yeah.
that is utilizing um, uh, doing neural network processing. That can be done at the edge. Um, so you can combine, so we're getting data from the cloud, such that then that processing, when it's doing that reasoning and that thinking, can happen on your AI PC. So that enables you to operate more efficiently and securely, right? So that data doesn't actually leave your personal device.
Oh man, this is opening up a whole bunch of interesting use cases in my crazy head of mine of things that I can do now, right? Because sitting on my laptop instead of pushing data up to the edge. There's lots of different things I could do, both in a personal thing, and I'm also thinking military
Mm-hmm.
use cases. Even like a FedEx driver. Can you imagine a FedEx driver having a large language model sitting on his mobile device right there? That would be super cool.
Yeah. Yeah. And I think when we see where AI goes, we're sort of in the what can it do phase, but we haven't really thought about what can it do economically. Um, uh, so like even in our own product, as we analyze where we want to do the AI processing, um, doing it in the cloud is expensive. And it depending on, how big the session is and how much you feed into the session. So being able to do it on the edge, you're going to be able to do the processing much cheaper. We sort of saw this with virtualization, the first time around, like when we looked to virtualize a desktop, for instance, which is basically running a desktop in the cloud. Um, a lot of the economics of that didn't make a lot of sense because like the processing power of a desktop, a MIP on a desktop, if I can use that term. Billy's going to stretch it for a second, ages me a little bit. The processing power of that, the cost of that compared to a MIP in the cloud is like a tenth. You know, the cost of the memory is cheaper on a laptop. So at the edge, you can do more compute at a cheaper rate than you can in the cloud. And I think when we start to look at what AI costs, once we get past starts to normalize as technology that people are using, people are going to look to optimize the cost um, to the use
Well,
case.
we're already seeing a huge impact on energy with all these AI data centers being built, like Stargate. I mean, Microsoft bought 3 Mile Island. Why did Microsoft buy a nuclear power plant? Well,
Exactly.
because they could put a data center on 3 Mile Island, right, and not have to pay the energy costs. That's crazy. Whoever would have thought that Microsoft would own a power plant?
Yeah.
It just doesn't make sense.
So yeah, I mean it's certainly a little back to the future, right? um, back when we were building big data centers for mainframes, back in the day,
Well,
and all that processing power was in the data center. And I think and IT is cyclical, right? I think people started to realize like maybe that's not the smartest model in the world because all of that consolidated power is expensive. So maybe client server computing made some sense. Um,
so do you think we're headed back? We're headed on a swing back into,
I think we
you
we
know,
are.
fatter clients?
I think so. I just there isn't enough electricity, power and data center capability to support where computing models are going. So you're going to have to be very selective on what workload you want to run in the cloud, and then you want to leverage the power of all these distributed devices that we have. Um, and yeah, so they're just going to run out of capability, right?
Yeah, now this is really interesting because now that I think about it, if I have an organization that has 1,000 employees and I give them all an AI PC, which the cost on an AI PC is not much more than a normal laptop.
Right.
We're only talking, a couple $100, maybe $300. Um, then wow, all of a sudden I have 1,000 NPUs out there running with GPUs as well. That means I could easily have 1,000 or 2,000 large language models running close to where the data is being generated.
Yeah.
That's pretty impressive. But how in the world do I manage something like that?
Yeah, there's gonna need to be tools built to do that. I think people are working on that. System management tools. But it's conquered ground a little bit. I mean, if you remember the old SETI at home, um,
Oh yeah,
you
yeah.
know, like
I did study at home.
and it was leveraging extra CPU power to conquer big models. And I think we're going to see tools and software built to to chop up LLMs and spin them out and have them, I think that's going to happen.
That would be pretty slick if I had a collaborative LLM cohort or hive. If for just my organization, where they, hey, my laptop's sitting there, probably plugged in.
Yep.
Why not use the cycles to help the corporation?
Yep.
That'd be really slick.
Yeah, well, I think I think we were starting to see people do that, and I just because the capacity won't be there in the cloud. So I think these are going to be good use cases for NPUs on top of just applications that'll be able to take advantage of them, like real time translation, all sorts of different use cases that NPUs really help with, right? So, like you and I are having a call where we're both talking in English, but I can see in the very near future, I could be talking English, you could be talking in a totally different language, or maybe I'd be talking in quad speak, and you would be talking at whatever speak, and
Yeah,
I
do
could be
large
talking.
models understand your quads? Do they understand their
Well,
secret
actually, I
language?
should probably say teenage speak because
Teenage speak. There you go.
I've gotten pretty. It's funny because you don't, like you lose touch of the teenage speak, and then when your kids become teenagers, you then become clued back in on it.
Oh,
But,
yeah.
but the language models could translate this for you on the fly, right? But you need.
In fact, we're starting to see some universal translator products. I think at CES, we're going to see it in droves at
Yeah.
CES, which is super cool. In fact, I use generative AI to generate my podcast, not my interview podcast, but I have a newscast that I do as well. And I generate that in 8 languages. I cloned my voice and my wife's voice, and we discuss the hot topics of the news in tech. And we speak 8 languages according to our podcast, all completely generated with AI. And it takes me less than an hour to do all that work. It's
It's
truly
unbelievable.
incredible.
Yeah, and if you're
Yeah.
going to want to do that in a real time basis, that's where
Yeah, that was
MPUs
so
become
cool.
fixed. You won't have time for that to go to the cloud,
To go to the cloud and come back.
come back. It's kind of why there's, I suppose there's GPU and NPUs on Teslas and cars, right? Because there's not the latency by the time it takes to go to the cloud and then come back, you hit something. So, that's why they're, rolling data
Yeah, all
centers.
you need is a downloading wait symbol on your
Right.
Tesla
Right.
as it's doing autonomous driving.
Right.
Just 1 second. Well, there's a stop sign. Oh,
Yeah.
loading,
Yeah.
loading.
Yeah. Hold on. Break. Be like my. I don't want to criticize my mom's driving, but
There you go.
that's mean.
But
I hope
the
she's not listening.
NPUs are really small too, very low power.
Right.
So I could really see NPUs being put into glasses, watches.
Yes.
Uh, so this could be really huge.
Yeah. That's. I hadn't even thought about that, but yeah, for sure. Like as we're trying to, wearing glasses and want to do real time diagnosis or recognition of what we're looking at. It'd be great use case for that.
Yeah, wow. I mean, the field is already it's ready for a lot of great new applications out there. So
Yeah.
tell my audience a little bit more about what you guys do with your company and why we're even talking about AI PC with you guys.
Yeah. So what my company makes a product called Systrax. So we work in sort of helping customers understand employee experience of their IT environment, devices, and things like that. Um, and one of the big things that people are wondering about is like what applications could take advantage of NPUs, what applications are using NPUs today. So we're one of the Intel launch partners on monitoring NPU usage and applications using NPUs to help IT understand, how to size these things, who it applies to, what workloads could go there, things like that. Really planning how you roll those things out. And then once you do, Are we using it effectively? Are we overloading them and things like that? So really system planning around that aspect and being able to monitor the performance of these desktops and laptops that have these NPUs on them.
So have you already started gathering data on, I mean, you have deployments out there already, and what are the trends that you're starting to see?
Certainly, early adoption is a lot to do with video imaging and conference calling and all that sort of stuff. That's already happening. As I mentioned before, we're starting to see people take advantage of running local language models, local large language models. Did we just make that up? Triple M, triple
Yeah.
LM, uh,
L3M, is that what we're
L3M.
yeah.
We're going to see more of that. I think enterprises are kind of like trying to figure out how to use the AI PC. Um, we get involved a lot with companies that are trying to figure out, like, as they replace their desktop fleet, is this the time to buy AI PC? So we work a lot with the OEMs on that, like the Lenovo's and the Dells of the world, to help their customers decide, like, should I buy a AI PC today? And how can I use them? So, yeah, I think, it's great for people doing a lot of video conferencing. I'll tell you that. You'll see a dramatic performance increase in team meetings, in Zoom meetings, probably even Riverside meetings, uh,
Yeah.
and things like that.
Yeah,
And
when you say performance, are you talking like battery life? Are you talking clarity of video?
all of it,
Um,
yeah, battery
all
life,
oh, really?
clarity video, battery life, um, in terms of network utilization, all those sorts of things. You optimize it.
That's incredible. Good. So this is almost the invisible, um, people don't think that that's AI.
Right.
Right, 'cause AI is something I need to talk to, and, that chat bot, because that's what ChatGPT brought to the world, was the chat bot, right? The AI, enabled chat bot. So this kind of AI is kind of hidden from the end users, but the benefits are huge in performance, efficiency, and things like that.
Yeah, I
Are
mean,
there other
if you ever been
Oh,
on
go
a
ahead.
conference call when you've got a bunch of kids screaming in the background and you think that people can hear it, but they can't,
Yeah,
that's
that's
AI in
AI.
the background, filtering that out.
Yeah, I guess most people don't even think about that. That's
Yeah.
just that invisible, tool. What other kinds of invisible tools are out there that, maybe we don't know about, but we're seeing the benefits through, things that we care about, like battery life?
Yeah, I mean, um, if you're using GPU can do the same things. It's just that GPU does them uses a lot more power to do them, right? So
Right.
battery life is definitely an invisible benefit. Yeah. So what we do is we collect data on the PC itself, and our architecture is we collect the performance information, and we store locally, and we process that data on the edge on the PC itself, and we use the NPU process to analyze and store that information, and then send to the cloud the analysis versus the raw data, which allows our platform to scale and in a cost effective way. Because if you have a solution that collects data and then just sends it in a stream up to the cloud, then you have to use cloud processing to process that data. So,
So I'm also decreasing the amount of data that I'm sending up to the cloud dramatically, I
correct.
would get.
Yeah, you're
Right,
sending
so I'm not
basically it's
hitting my network. I'm not
right.
wasting network bandwidth and
Yeah.
things like that. Yeah, man, I can start to see a lot of other use cases. I know, some other partners are using it for, a malware detection,
Mm-hmm.
right? They put it directly in the NPU instead of using a GPU to do pattern recognition, to
Mm-hmm.
say, "Hey, this looks like malware."
Yeah.
So that's pretty. when you think about it, we can use these NPUs to do a lot of things that before were slowing me down, right? I hated it when the software detection, malware detection thing kicked in because I could always tell when it kicked in because my machine would go, "Whew."
Oh yeah, yeah,
Now I don't even notice it because it's
yeah.
happening.
I
It's
mean,
a
the
decent level.
security, the impact to the security tooling. You're absolutely right. Like the ability to respond quicker to these threats, rather than having to farm them back to the cloud, analyzed and back. You can do that analysis right there locally. Yeah, that's a great use case.
Oh,
Um,
that's awesome.
and not destroy the performance of the machine, which, you know, traditionally there's this sort of line between like protecting the user from hurting themselves to giving them performance so they can actually get stuff done, right? So there's this line. So if we can make it more effective, you can be secure and be able to do what you want to do, which
Yeah,
is,
no, exactly. I was talked to security people, and I said, "What's your optimal security footprint?" And they said, "In a concrete bunker with no connection to the internet."
right.
I'm like, "Okay, it's totally useless, right? Totally useless with
Yes,
no USB keys to plug anything in." Yeah,
right.
yeah, that's the ideal. Um,
With
uh,
a
we're
3270 VT100 terminal, right?
exactly.
Yeah.
That's exactly right. But, that's not reality. So I really love that, we've got another, processing unit that can be tailored to specific use cases like NPU. Do you think we're gonna see other types of processing units being developed for specific types of use cases? I mean, NPU is still kind of broad, but do you
Well,
see other ones being developed?
Well, you started to talk about glasses and some other IoT devices. I mean, I could definitely see, um, so a PC is a general purpose computing device. So I think,
Right.
you probably need a general purpose NPU device that's optimized that people leverage. But I think when you start talking about IoT or OT, operational technology, people using, video cameras and all sorts of things, I could definitely see specific workloads optimized on those devices or single purpose devices versus general purpose devices.
Oh, for camera object detection
Right.
or, threat detection, right? Um,
We
we and there are specialized, processing units that do vision. Um,
Right.
in fact, that's what a lot of the autonomous vehicles are starting to use is,
hmm
specialized, processing units. So cool. This is really cool stuff.
Yeah, we're sort of scratching the surface, I think,
So,
on
um,
where all this
eh
stuff goes.
yeah, AI is not, bringing computing to an end. It's unleashing even more, it sounds like.
Yeah, I mean, nobody knows where it goes in the end, but certainly, um, we've seen these cycles in technology, right? The invention of the internet, that didn't bring uh, businesses to a close. I mean, it really optimized things and brought up new ways of doing things. I'm sure the same will be with AI. Um, in software, I mean, it's affecting software a lot. But I think I've read something where there was millions and millions of hours of backlogged software projects that people never got to. Now people can get to more stuff, and
Yeah.
automate more things, and so um, it's going to be real interesting where it all goes. And look forward to what the kids are going to be doing, like
Oh, I know.
in the future. um,
Oh, speaking of kids, what your kids, started college this year, right?
yep, yep.
Alright, so what are they studying? Are they all studying, all different subjects?
Yeah, I mean, we've got one studying sort of economics, math, um, a chemistry, a biology, and a biomedical engineer are the
Oh,
four,
wow.
all sort of sciences. Nobody doing computer engineering, which is what I did. um,
They'll come
I got
around to it. Give them some time, Dan. They'll
my
come
my
back.
and my wife's a lawyer, so we'll see where that goes.
Oh,
So she's pushing them hard that direction.
yeah, maybe you'll get some patent attorneys in there. You never know. So, hey, Dan, this has been great. If people wanna learn more about, you or your company, where do they reach out?
just lakesidesoftware.com. Contact us there.
All right. Perfect. And you're out on LinkedIn as well, I'm assuming, Dan?
Yeah.
All right. Perfect. Well, hey, Dan, thanks for coming on the show. This has been a great conversation.
Yeah. Thanks, Darren. Thanks for having me. Congratulations on the 10 kids. That's amazing.
Oh, hey, thanks. And for quadruplets, man, I bow to your wisdom on that one. That's tough.
Yeah. Oh, it's fun.
Thanks for listening to Embracing Digital Transformation. If you enjoyed today's conversation, give us 5 stars on your favorite podcasting app or on YouTube. It really helps others discover the show. If you want to go deeper, join our exclusive community at patreon.com/embracingdigital, where we share bonus content and you can always connect with other change makers like yourself. You can always find more resources at embracingdigital.org. Until next time, keep embracing the digital transformation.